Good morning, everyone, and thank you for joining us today. My name is Michelle Jones, and I'm your moderator for today's panel discussion. We have representatives from Canadian leaders in battery electric bus, R&D, and manufacturing. Today, we will explore the latest design improvements in batteries, bus range, charging optimization, and seasonal performance. By sharing data and outcomes from vehicle deployments across North America, this panel will provide unique insights into the accelerating decarbonization of Canadian and global transit and how it's being shaped by Canadian innovators. Before we get into our discussion, we'd like to play a video from our sponsor, ZEV Clean Power. Thank you. Video. First, I'd like to bring up Jennifer Mcneil, our first panelist. Jennifer Mcneil is a transportation industry veteran with over 2 decades of leadership in transit bus manufacturing and aerospace. She joined New Flyer in 2012 and currently leads the sales and marketing operation while also providing strategic business intelligence direction. Prior to New Flyer, Jennifer had senior management and leadership positions in engineering, quality, sales, and business strategy, including Vice President of Sales, Marketing, and Business Development with Standard Aero. Jennifer is a catalyst for the development of the New Flyer Zero-Emission Vehicle program offerings in Canada and United States, and is a board member with the Canadian Urban Transit Association, CUTA, and the Canadian Urban Transit Research and Innovation Consortium, CUTRIC. She holds both a mechanical engineering degree and a Master of Business Administration from the University of Manitoba and is an accredited professional engineer. Jennifer, welcome. Thank you.
Thank you, Michelle, and good morning. Hello, my name is Jennifer Mcneil, and I'm the Vice President of Public Sector Sales and Marketing for NFI Group's North American bus and coach business, which includes New Flyer and MCI. I join you today from Treaty 1 territory, the original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, Lakota, and Dene peoples, and the birthplace and homeland of the Métis Nation. Of mobility solutions and one of the largest bus manufacturers in the world. And it looks like having problems here. I'll continue. I'd like to thank the CUTRIC team for hosting yet another virtual zero-emission bus conference, and I'm pleased to join this panel and to share our most recent advantages and advances in battery electric bus technology. A little over a year ago today, New Flyer launched its next generation battery electric bus, the Excelsior Charge NG. Oh boy. Are you? Which has 3 distinct technology advancements. The first technology is a more modular and streamlined battery enclosure, designed and manufactured by New Flyer. Each enclosure, which we affectionately refer to as a juice box, contains 1 battery string comprised of 7 modules connected in series. This standardized waterproof battery enclosure is IP67 and IP69 rated, lighter, insulated, and sealed from the environment with desiccant cartridges for humidity control. The enclosures feature 90% fewer parts than the previous ESS, touch-safe, quick connections, and can be easily swapped off buses if needed to be tested or repaired on a bench. The same standardized enclosure is used in multiple locations on the vehicle. 4 enclosures on the roof and 2 in the propulsion compartment. And as a result of this design change, the battery thermal management system was also modularized, replacing approximately 350 components throughout the vehicle with 1 unit. The second technology was an upgraded traction drive system, the Siemens Alpha 3 technology. The system itself has increased power and torque and upgraded motor controls, providing better gradability as well as smoother acceleration and deceleration, especially at low speeds. It also provides up to 90% energy recuperation through braking, which helps with range. But probably the most impactful improvement of the Alpha 3 system is the improved packaging of the inverter rack. The Alpha 3 inverter rack is much lighter, more compact, and fits within the propulsion compartment. This means that both high voltage and low voltage cable runs are significantly shorter, taking weight and complexity off the bus. And our last new technology is the latest generation high energy batteries with increased energy density. These batteries extend range by 13% and provide greater capture of regenerative energy during braking. In 2021, NFI launched 6 new zero-emission vehicles. The Excelsior Charge NG and Excelsior AV are effectively the same platform, both launched in Q1 of 2021. ARBOC launched their medium-duty low-floor transit bus, the Equus Charge, in February of 2021. MCI launched the D45 CRT LE Charge and J4500 Charge electric coaches in May of 2021. And Alexander Dennis launched the E500 EV Charge double-deck bus in June of 2021. And as we move forward with our technology roadmap, you'll start to see the product improvements I just spoke of incorporated throughout our North American vehicle portfolio. The Equus Charge, for example, also includes the standardized battery enclosure, next-generation batteries, and Alpha 3 motors. But we cannot talk about battery electric buses without talking about charging and infrastructure. By the end of 2021, NFI had installed almost 300 chargers in over 50 cities, both en route and depot chargers. Our solutions have ranged from providing equipment to full turnkey project management with service level agreements. Charging has experienced incremental development with many charging standards making significant progress last year. NFI works with multiple charging manufacturers, many of whom are here today and will provide updates on their technology. But over the past year, we've done significant work with our charger manufacturers, adding models to our charging catalog, commissioning, and ensuring real interoperability and charger availability. These projects have been relatively small, but have given us a good idea of the challenges that adoption at scale will bring, ensuring successful charge completion of large mixed fleets and managing peak demand. So as a result, we've spent a great deal of time working on communications between buses and chargers, as well as charge management technologies. Which brings me to connected vehicles. There is a growing demand for connected vehicle data sharing. We know that range and energy consumption data are critical, especially with agencies who are developing initial launch plans. Some of the improvements on the horizon to overall vehicle diagnostics and troubleshooting include more intelligent fault codes with clear problem identification and subsequent action, predictive maintenance and trend analytics, and more integrated and universal diagnostic solutions across all vehicle components and charging infrastructure. Throughout the year, we also developed a deeper understanding for functional safety and cybersecurity, both as part of core vehicle design and infrastructure networks, which is why we recently announced joining ITXPT, the Information Technology for Public Transport. ITXPT is a global nonprofit association that enables open architecture, data accessibility, and interoperability between IT systems. Ultimately, we need to start looking at the bus as a digital platform and full mobility solution, and be more concerned with the sharing of data rather than the integration of multiple telematics solutions. This is a fundamental shift that we need to consider. No longer can we simply prescribe the components we want assembled on the bus. We have to also consider the system's impacts, interoperability, and cybersecurity. So the past year has brought about a number of incremental improvements to battery electric bus technology and has brought us closer to the 1-to-1 replacement ratio we are striving for. I'm confident that we'll continue to see battery technology improvements every 18 months or so, and NFI's technology roadmap has set us up for seamless incremental improvements. But unlike conventional propulsion vehicles or even hydrogen fuel cell vehicles, there is a connectivity and interdependency between buses, chargers, and the utility that makes battery electric buses more of an ecosystem than individual pieces of equipment. If I could leave you with one thought, both from the technology advancement perspective and the workforce development perspective, it is to always consider the areas of overlap between bus and charger and utility, and as we get to the development of standards for exportable power, bus and utility. Thank you.
So much for your presentation. When we get into the Q&A, I'm sure that the audience will be excited to ask more questions about the innovations that you spoke of. Our next panelist is Milan Tassie from Novabus. Milan is recognized in the field as a natural leader who has been honing her skills throughout her 25 years of experience, mostly in aerospace, but notably as Vice President of Sales, Business Development, and Marketing at Thales Avionics Canada. She boasts a deep understanding of the fields of engineering, sales, proposals, and marketing in aviation and other sectors. Her business development expertise recently earned her a spot in the Excellence 2020 cohort, an initiative that recognizes leaders who are making a difference in the business and philanthropic landscape. After earning 2 bachelor degrees from McGill University, one in mechanical engineering with a minor in management and the other in environment and agricultural engineering, Milan further boosted her skills with an MBA from the University of Cumbria, UK in 2018. As Novabus Vice President of Sales and Marketing, Milan will lead the sales, marketing, bids, and proposals, sales engineering, and project management teams. Thank you.
Thank you so much, Michelle, for the introduction, and thank you to Kurtrik for allowing me to be part of this presentation today. First slide, our bus in the streets of Vancouver, our 100% battery electric bus, the LFSE Plus. Proceed. So Novabus is part of the Volvo Group. The Volvo Group is a manufacturing leader in all forms of transportation. Over 100,000 employees worldwide, operating in 18 countries, investing strong investment in R&D, which is at the core of the Volvo Group. How do they move the needle forward faster, safely, and in a more cost-efficient way? Being part of the Volvo Group allows Novabus to leverage everything that's being done in Europe, and also in order to move and to address an offering to our customers that is more adapt to their operating need. Yeah, and that's it. So going to the next slide. So the Volvo Group, specifically as far as the bus industry is concerned, is one of the world's largest producer of heavy-duty buses, coaches, chassis, transport, etc. So once again, we benefit from what they do. For example, recently, they have a joint venture for European high-power charging infrastructure in order to adapt it to the North American market. Novabus range of buses. So we have buses in multiple propulsion in order to make sure that our customer can have uninterrupted service and meet the customer's needs. So going to point A to point B, propulsion from the legacy propulsion, so obviously diesel, CNG, and hybrid propulsion as well. We basically bring the track record of the LFS range of product, over 10,000 buses operating in service, known for their durability, their reliability, their safety, their service network after sales, in order to leverage that in our 100% battery electric bus. So we build on our base. We're currently now at a turning point in our industry, the transportation industry, and perhaps even in our society. We really see an equilibrium between the education about climate change, the economic growth that we seek, and the environment. The protection of this environment has been at the forefront of our thoughts and our priorities, and has precipitated decision to promote a cleaner, more responsible society. And transportation is the key in that. So in order to discuss and be part of this change, of this transformation, we started thinking about electromobility. And we really wanted to talk about electromobility in more of an ecosystem, because we know it's not just a bus. There's so many elements that came into play, as you can see with the image, that are necessary to ensure an actual successful deployment of electrical mobility fleets. And we really wanted to look at it from the perspective of our customer more than our perspective, because at the end of the day, we serve the transit agency who serve the day-to-day citizens in order to go from point A to point B. It's an essential service. So how can we be part of this journey with our customers and really see how the building block of this ecosystem work and how we can alleviate some of these building blocks for our customers, so we make electrification of fleet faster, safely, and also more economically as well. So looking at it as an ecosystem, this is a preliminary view. It's evolving. As we know, with the last 2 years, we know that adapting to change is a key element to success. So we have to be agile and see how it evolves. But this is a preliminary view. Obviously, we have the bus. We know we have the bus, but it's not just about the bus. Historically, funding has focused on the bus, but we know that for electrification of fleet, it's clearly inefficient, not enough, in order to ensure a zero-emission transit system that is functional, reliable, and cost-efficient over the life cycle of the fleet. So there's much more than that. And looking at it as an ecosystem, it allows us to also understand what are the pacing items of this ecosystem. How fast will the deployment actually be? And it gives us a credible read on the market in terms of the volume of the deployment and the timing of the deployment as well. So going through the building block of the ecosystem, we have the bus, which we have an offering for, but we know as an OEM provider, a bus OEM provider, that we have to go above and beyond and see how do we alleviate some of those building blocks for our customer. How is our product offering allowing our customer to have a better understanding of the charging infrastructure, to know what they have to do at the depot, what they have to do en route, how do they manage the charging, how do they implement software, smart charging software solutions. Route planning, at the end of the day, once again, it's all about getting from point A to point B and making sure there's uninterrupted service for the end user. So how do we make sure this is at the center of our being, the center of our objective? The depot, massive footprint that has to be overhauled to host now new propulsions and new propulsion safely. How do we help them park the bus in the easiest way possible, from the front, from the back, so that for them, there's one less thing to think about. Service support. We know that there will be some problem because this is a new technology. It's inherent to any new technology and new solution. However, to have trained staff at your disposal close by is important to make sure that the bus is down for the minimum time possible. Training of the workforce. Training the workforce in this new technology, high and low voltage, safely, having an engine compartment that has easy access, that it's clean, that it's crisp, it's very important. And also attracting new workforce to this new innovative technology that answers the needs of society. And of course, telematics and diagnostics, so storing, receiving, transmitting data, and having the ability to diagnose the data, so fault isolation, fault reporting, diagnostic, troubleshooting, etc. There are pressures and barriers to entry, financial, but we see, as far as financial, that multiple levels of government are aligned to make sure that this is a priority. This is a priority. We need to make sure that we put the funds, the knowledge together to ensure that we are successful in deploying massive clean transportation for all. Obviously, technology roadmap, once again, if you look at it in an ecosystem, you have a better understanding of what is pacing the item and the availability of the workforce. All that is, of course, dependent on a strong partnership with your utility provider to ensure that energy management protocols are undisrupted and are at an economic value as well. So looking at it over and beyond what we produce at Novabus, the electric bus. However, what is our approach into electromobility? So we went to three-step approach. First, we built on our base. So we use a platform that has a track record, the LFS platform, and we basically electrified some subsystems slowly with the hybrid electric bus. So using the hybrid electric bus, over 3,000 buses in the route, operating successfully, leveraging this information, and then implementing 100% electric subsystem for 100% battery electric bus. So building on our base, first step. Second step, taking advantage of real, tangible, operational data. So Novabus was the first in the market with an electric offering for short range in 2017. They tested their test fleet in 3 specific regions in Canada. So Montreal, around the city of the Old Port, and if you know the Old Port of Montreal, not easy street to navigate. In Ontario as well, and in Vancouver. So testing over our beautiful country and checking and making sure we have substantial, tangible data for operation. And last but not least, taking advantage of everything that Volvo brings us in terms of smart charging, battery technology, infrastructure in order to address it and modifying for the North American market. So this is our approach to electromobility, which leads us to our 100% battery electric bus offering, the LFSE Plus, which has 100% electrical propulsion. We provide modular system, which allows for easier access, less time for maintenance, safety as well, in order to ensure that the offering works operationally and also that it's easier for the workforce to train on in terms of any issue that might arise while it's operating. So I'm going to skip to this slide, actually. Going back to the battery electric bus. So, you know, when we mentioned the ecosystem, so there's the bus, there's a charging infrastructure, which I'll address in the previous slide, but there's also everything that has to do with the modular approach. You can see the ergonomic, the way the ESS, the energy storage system, are ergonomically placed at the roof of the bus. The modular system from BAE, so the modular accessory power system, the modular power control system, so the modular power control system, which draws the energy from the ESS, from the battery, and then distribute it to the MPSS, which distributed to accessory. A modular approach, clean, easy. I wish I had a picture of the engine department. It's beautiful, it's clean, easy access to high-low voltage. So it promotes safer operation of that bus, which is super important. And there's less parts, less breakage, less time taken to basically fix, to maintain your asset. So more time to use your asset on the road, because this asset costs more. Make sure you have to utilize it and optimize it to the best of the ability. It has to be on the road as much as possible. So that is our approach to not only the battery electric bus, but also to alleviate some of the building block with the perspective of the transit agency. So going back to the winning condition to implement battery technology. So obviously we have the AC traction motor, we have the modular approach to our control system, we have the modular approach to our accessory power system in order to alleviate the time for maintenance, to make it easier for the workforce to be trained as well. But those battery technology is an important part of this new mode of transportation. There's some barriers to entry. We've talked about it before, funding. They seem to be aligned, but then there's a question of timing as well in terms of the technology. So there's a complexity of integrating the charging infrastructure, upgrading facility to meet the increased power demand, workforce training. Very important to have a strong partnership with utility provider and to have standard management, energy management protocol as well. Performance handle, obviously it's about range. It's always about range anxiety to ensure that the route is not in danger, the route is maintained from going to point A to point B for the end user. That's very, very important. The conditions, the way you operate, whether it's in the snow, the ice, whether it's hot or not, if it's an incline or flight terrain, all that influences how the battery will behave. So how do we help you and help the transit agency to address these barriers to entry, to address these performance and hurdles? We work in close collaboration with our customer to optimize performance based on their local condition. We have strong data analysis of similar location, model simulation, planning design, vehicle testing, and as we know, we did some flight testing also in Montreal, and we optimize the range and the battery durability. It will take a different type of partnership. We have to work closer with our customers in order to address this as an ecosystem and really ensure that together we move the needle faster and we successfully deploy to the masses the electric and clean form of transportation. I think I'm over my time. So
yes, Milan.
Thank you so much.
Good morning, and thank you for your comprehensive presentation. Look forward to the Q&A where we can discuss more of this e-mobility ecosystem. Our next presentation is from Jonathan Leskowicz. Jonathan is a senior engineer with 20 years of experience in the heavy-duty and transit industry. Jonathan has served in many leadership positions, including being the engineering manager at Coast Mountain Bus Company in Vancouver. In his current position as Vicinity Motor Corporation, he has been leading the development effort for the Vicinity Lighting midsize electric transit bus. He chaired the Maintenance and Vehicle Technology section of the CUDA Technical Services Committee for 3 years and has volunteered to lead numerous other groups and workshops. An expert in alternative fuels and vehicle standards for design for market applications, Jonathan is always innovating while working on new ideas within the industry. Welcome, Jonathan. Thank you.
Good morning, everyone. It's a great day to talk about battery electric buses. I'm very thankful to be here, and I thank you, Trick, for letting me present. Thanks, Michelle, for the great introduction. Like Michelle said, my name is Jonathan Leskowicz. I'm the Senior Director of Engineering and Product Development at Vicinity Motor Corporation. So today I am here to talk to you about some of the innovations we're working on. Wait for my slides here. 4 main topics. The fleet solutions we have designed to be electric, how we've used innovative components to create cost-effective performance, reducing charging infrastructure, which equals lower EV entry costs, and what the path forward with BMC really looks like. So lots of new vehicles, and this is really exciting for me, probably exciting for you guys out there too. First one I'll talk about is the E1 Paratransit chassis. So this is your typical high floor shuttle. It has 6 mobility aid positions, fully electric, and something you're very familiar with. The next one is the S1. This is the very innovative chassis that includes a wheelchair ramp and 3 mobility aid positions. Now that ramp is extremely low. When it folds out, it ends up being as low as a kneeled bus. So this is great for accessibility. And then the flagship Vicinity Lightning Bus, as Michelle said, I've been leading the development for. So this bus is 28 feet overall length. It's a little bit more heavy duty than the E1 or the S1. And that's because it's meant to be used as a cross between a shuttle and a light duty transit bus. So if you're really looking, if you've got routes that have a little bit more people, or you want a bus that looks like a bus driving down the road, this is the bus for you. So going back to the E1 and S1. So the S1 here, I just wanted to show you these pictures of the accessibility and where the battery and the motor are located, just giving that very, very low chassis and great accessibility in it. This vehicle also reduces the need for a costly ADA lift in the back, so really reduces the price on this shuttle. Here's some of the seating configurations for those transit geeks out there wanting to really see what you can do. So this one includes 3 mobility aid positions, where you can have luggage rack or full seating. And then going to the flagship model, some of the really neat features of this little bus are that it comes with full air ride suspension for passenger comfort. Also has an optional second door. What I really like about this bus is it has dedicated driver AC. For those drivers out there that have driven conventional buses, you'll know that the air conditioning often comes from the roof. On a shuttle bus, it comes from the dash because it's often a GM or Ford chassis. In this bus, we've designed it so that it also has those vents in the dash blowing AC on the driver. The driver can keep himself at whatever temperature he wants while the passenger's at another temperature. That also increases efficiency by reducing heat load. This bus also incorporates a heat pump and a large view windshield. So again, this bus is completely ADA accessible, 6-to-1 ramp in the front, a very wide entranceway and a true low floor design. The batteries are mounted in the floor and they're expandable up to 339 kilowatts with the Proterra choice. And we've now incorporated a new motor called the X-Row Coil Driver. It really gives us best-in-class gradability with 395 horsepower. That's a huge jump. And I will talk a little bit about our Charge Anywhere infrastructure. So part of the floor plan here, I just wanted to show you this. On the previous slide, it showed that the vehicle uses 19.5-inch wheels and hydraulic brakes. And why that's been done is to keep it in line with shuttle technology for people operating shuttles. It makes it a lot easier to maintain. Additionally, these wheel wells, as you can see, this red box here going through the floor plan of the bus, that's the New York City box test. Having those small wheel wells enables us to pass this test, which can be difficult even for larger buses. And then you can see here that you've got the 4 mobility aid positions, and you can still have a rear door and that 4th mobility aid position as well. So very versatile bus. The other thing I would like to mention is that because this bus was designed from the ground up to be electric, the engine compartment was very much reduced in size from its diesel counterparts, and that really pushes the inside interior of the bus out. It's only 96 inches wide, 28 feet long, but I guarantee you that it feels like and acts like a 30 to 32 foot bus because of the efficiencies in the actual envelope that have been designed in. So getting to some of the really new technologies, the X-Row Coil Driver technology is something I'm very excited about. It really gives you the grunt at the low speed and the efficiency at the high speed, which is so important in a shuttle type vehicle where you're traveling at high speeds. So you can see in this graph here, the X-Row motor is this blue line, and it comes up and it kind of plateaus and goes up again. And that's because it's got 6 phases, and it shifts from 3 phases for high torque in the beginning to 3 phases, and it shifts an entire torque curve to the next motor speed. The red line shows you a typical 2-speed gearbox type motor, so you get this hole in the torque curve, but you still get that efficiency at the end. And the yellow line shows you one of those, like a large, typical maybe hybrid bus motor where you really lose efficiency and power at the higher speeds. So that's a great innovation there. And also what we've moved to is Proterra batteries. So that gives us 226 kilowatts in the floor and then up to 339. Now that 3rd battery is actually mounted in the back, not the roof. And the reason we do that is to create a great handling and stable platform. I spent my life, beginning of my life, driving trucks, buses, dump trucks, everything. I was a professional driver. I really know what it's like having load up high, and this is a great way to create drivability. So another really great innovation is charging, because with the X-Row Coil Driver technology, what we're able to do is kind of really shift what conventional charging looks like. So on the left here, you can see a conventional bus with the AC or DC charging station and then the charger on board potentially. Now with our bus, you have no charger on board, so that reduces the cost of the bus itself, and no need for a charging station. So this bus is able to plug into basically any type of power you have, whether that's 3-phase AC, DC, whatever you have. And if you have enough power, you can charge right up to the motor power, so up to 295 kilowatts, if that's what you needed to do. So that really reduces cost for your entry to the EV market. You're not having to run around and buy all these charging stations. You're buying less expensive buses because they don't have chargers on them. And that's what we're really trying to do here. This is also grid storage capable as well. So what does it look like going forward with VMC? Well, we're building a facility in Ferndale, Washington, another great initiative. This is going to support our Buy America orders, but as Canadians, you'll be able to order your buses through this facility as well. So you'll be able to come down here, tour it, see the technology, see the people, see the buses. Thanks, everyone. It's been great to present.
Presentation, and we're going to bring up our other panelists as well so we can get into the Q&A portion, which I'm sure the audience is waiting for. I'm just looking to see if all the other boxes pop up. Jonathan, we got Milan and Jennifer. So I'm going to just start asking questions to all of our panelists. And the first question, I'll make it a little bit easier in that, what has been your most challenging deployment and why? And I'm going to start with Jonathan.
Most challenging deployment, like a bus order?
Yes. Yes, your most challenging bus deployment and why?
I think I would say that recently with COVID, there's been lots of challenges, and I think that everybody would probably mimic that from me. I can't think of one in particular, but you know, there's been struggles in the industry for sure. There's a lot of hoops to jump through right now. We've had success. We've been able to deploy buses, which has been good. But yeah, that's what I would say about that. Okay,
thank you. Jennifer?
You know, each one of the deployments has had its own nuances and challenges that we've had to work through. You know, I think the one that I would pick would actually be Los Angeles. And so in this particular deployment, both ourselves and another vehicle manufacturer were deploying vehicles onto the same route where New Flyer was responsible for the overhead charging. And so that was our very first foray into what real interoperability meant, and actually having both manufacturers' vehicle work on the chargers consistently and reliably. So that, I think, was kind of that eye-opening moment for us.
Thank you, Jennifer. And Milan?
So I'm going to echo the words of Jonathan. It's been a crazy past year for sure, and to make sure that we manage the issue in terms of global supply while still meeting our customers' expectation has been a constant challenge for sure. And because this is a new form of propulsion, a new form of movement into our industry, there is more than just a bus. So echoing Jennifer's comment in terms of making sure there's an alignment with our infrastructure provider and that it fits the needs when you're actually on the field of our customer for their depot, their en route is always a challenge that we have to keep in mind, and to make sure that everything goes smoothly, not just our bus, but everything that is also overlapping. I'm using your term, Jennifer, again, the bus itself.
Okay, so you said something key there about global supply chain there, Milan. And so how has the global supply chain constraints affected the zero emission innovation, and what are your hopes for a post-pandemic world?
I guess I'm first.
Yes, I'll start with you first. I'm sorry. Yes.
So obviously the global supply chain has affected everybody. So we're not different. We're just part of the industries that have been affected. Obviously, for us, we're an essential service, so it's a bit of a double whammy in our case. And also, we're transforming our industry. So my hope is that we've looked at different ways to try to predict what can happen in terms of our supply chain. So we've looked at multiple sources. We've also helped our suppliers. We try to anticipate by reading the market as much as we can. We don't have a crystal ball. What are the roadblocks that are coming up? My hope is that it ends, and then that's my hope. And soon.
Yeah,
that's my hope.
Definitely. Jennifer?
You know, the global supply chain has impacted manufacture of all, you know, automotive vehicles in many, many different ways. And, you know, if I was describing it as a game, it's a little bit like whack-a-mole, where you kind of solve one supply chain challenge and the next one pops up. And so I think that right now we are really just reacting to immediate challenges, but longer term, I am really hopeful that, over the next 6 months or so, things sort themselves out. And we're really kind of working more in a planning and execution in a more seamless manner. What we have done is actually quite a bit of long-term planning and expanding our time horizon from a typical 12 to 18 months to more like 5 years, and looking for depth and capability in our supply chain. So going a little bit deeper to understand how they plan and support them through, their journeys, whether it happens to be labor or quality or even their sourcing. We've actually reached out to many of our supply chain partners and helped them make their supply chain a little bit stronger as well.
And Jonathan, to wrap up this question here.
Well, I'll second the whack-a-mole comment. Very true. Yeah, one of the ways we've tried to not play whack-a-mole though too is really to basically, simply put, buy ahead. So trying to source the components and get agreements in place to get those components before anybody else is buying up the chips, like basically, in a way. And we've had success with that. It's difficult for an organization though. You're looking at really putting capital towards stuff that you would buy somewhere down midway down the order or whatever, and you're buying it all ahead and having to fund that and raise money for that. So that it's a struggle. I'm sure it's a struggle for everyone too.
Okay, and I'm going to then transition to one of our first audience questions. This is from Christopher. The question is, with battery electric storage system contributing to 40 to 50% of the total bus costs, does New Flyer Industries, Novabus, and VMC consider manufacturing their own batteries, not just relying for third-party battery manufacturers? Jennifer, I'm going to start with you on that.
Well, when you actually look at the energy storage system, New Flyer does manufacture a good amount of it. What we do not manufacture is the actual battery modules. So those we are sourcing from multiple locations. It quite honestly isn't our core competency. But once we get the modules, we are basically doing the assembly and packaging and everything sort of beyond that. We're really proud actually of our new battery enclosure, which I referred to as Juice Box. It was designed and manufactured by New Flyer and one of our subsidiaries, Carfair, who does all of our composite manufacturing. So, we're pretty vertically integrated, but the battery modules is a very specialized skill set.
Milan?
Thanks, Michelle. So for me, when I look at any product, so the way I define product is always an asset that can be sold. So it's not an engineering project, it's an asset that can be sold. It's about what is the most cost-efficient way to get there. So for us, the most cost-efficient way to get there is to partner with a battery provider. We also leverage everything that Volvo Group is doing. They're a global supplier of battery, of robustly designed batteries as well. But we have felt that this is the best cost-efficient way to do it for our customers, and also has a bit more control in terms of supply and lead time and so on and so forth. To me, it's very important to make sure that overall, we're not expert in everything. We all have our expertise, but the objective is to partner with the right industry, the right partnership to offer the best value offering for our customers. So that is our approach.
Thank you, Milan. And Jonathan?
Well, the battery industry is very volume driven. So in order to compete there, you have to have massive volume. And the bus industry is customization driven. So the two industries are very, very different. Therefore, I wouldn't try and manufacture my own cells at all, because in order to get the correct pricing on them, you want to go to the person who's got the biggest volume.
Okay. And I'm just looking for one other specific question for you, Jonathan, that was sent out. Before I ask another battery question, one of my battery questions as a transit agency.
Mhm.
So I'm just looking at this question, and it says, it's about range, right? And Jonathan, what is the additional range with the added battery, and how does that impact your passenger capacity? And that is specific from your presentation.
Okay, so
Sorry.
actually,
Yeah.
with the extended range Proterra pack, we don't affect our passenger capacity. We're still within our axle and tire limits on our bus. So your passenger capacity is still full, even at 339 kilowatts. How it affects range is going to be really dependent on how you're running the bus. But our expectation is you're going to use about 1 kilowatt per kilometer. So if you have a 339 kilowatt pack, then you're looking at, effective usefulness of that pack is 80 to 90%. So you're looking at about a range of about 300 kilometers.
Okay. Thank you, Jonathan. And thank you for that question, Randy. So my question as a transit agency is more about the second life for batteries. So what are some of the innovative thoughts for the use of the battery after they're no longer useful enough for the propulsion technology? And does your company have any actual solutions or projects on the go, or are they even concepts to think about the second life of the battery? I'm going to go with you, Jonathan, and then over to Milan.
Well, currently we're working with both BMW and Proterra. Both those manufacturers actually take the battery back for recycling when we're finished with it. They might have other solutions. I don't know how much of the battery they're reusing or what exactly they're reusing on the battery, but those batteries do go back. And that's one of the benefits of partnering with a larger battery manufacturer, because they have plans for things like that.
Good stuff. Thank you. Milan? Yes, Michelle, thank you for your question, because we always talk about clean transportation, but then what do we do with these batteries? Are they just going to be waste? So obviously that doesn't work, because the concept of circularity just doesn't work there. So definitely, again, I'm pushing Volvo. We're benefiting from the fact we're part of a larger group. They have specific department that look at Volvo Energy, which basically is all about refurbishment, remanufacturing, recycling, second life, either on the bus or second life outside of the bus. So definitely there's project ongoing as far as that is concerned, not only to make sure we have the right price point, we evaluate ourselves properly, but also in terms that we actually are contributing to this clean transportation overall, over the entire cycle, and not just with our product.
And then Jennifer, I'm going to wrap up on that question with you, please.
Sure. No, it's a great question. There are several paths that one could take. First of all, we hope that the batteries are on your bus for the entire 12 to 18 years. But after that, we also have partnerships with recycling partners, most recently Li-Cycle. As well, our battery manufacturer does use recycled active materials. And I do think that the commodity market for these active materials in batteries will actually become very important. And so that might be the best use of batteries at end of life. However, we have spoken both with our battery manufacturer and some utilities around the idea of using second life batteries for energy storage and charging applications. We haven't yet come to a case where it actually makes sense to do that, but it is something that we are exploring.
Okay. This is a question related to the pandemic, actually. And so with the pandemic, what technologies are you incorporating into your e-bus to avoid COVID transmission in the bus cabin? Jonathan.
We have incorporated a standard hygienic shield into the bus driver compartment. So this is just like basically a glass barrier. I think that's very common for everyone, but it's just comes standard now on the bus. Additionally, we use a technology that employs, it's actually hydrogen peroxide and UV light. If you want to get that on the bus, it's a circulatory system. So it's circulating with the HVAC system, and it will kill the virus as you're driving down the road.
Okay.
Yeah.
Jennifer?
Very much the same. We do have a number of driver barrier technologies that we offer, both ones manufactured by New Flyer and ones by our supply partners. As well, our NFI Parts team has a Clean and Protect product, which is quite similar. It's an air purification system that kills the virus.
Okay, and Milan.
Ditto. So very much the same thing as well. Hopefully it kills the virus, right? I don't know if we can claim that, but definitely purifies the air so that there's less chances or decreases the probability of virus transmission, and obviously the barriers as well.
All right, thank you. So I have another question here, and I already lost it in the chat. I apologize. Let's go to I Like Tech. So let's talk about telematics. So what kind of live vehicle telematics data is generated by these battery electric buses to assist drivers, dispatch operations, and maintenance? I think I'm going to start with Jennifer.
Do you know, pretty much every system on the bus has a telematics solution right now, which is kind of both a blessing and a curse. We have multiple solutions with multiple antennas, which is getting, as I mentioned, a little bit chaotic. However, our NFI Connect product basically pulls all the data off the J1939, the CAN-lock system, and then we decide what to do with that data to make it into useful information. And so for our electric buses, we've created our Connect 360 reports, and those reports will provide everything from tracking the GPS position and topography of the vehicles that have been deployed, to the energy usage and how it's split between the propulsion and the accessories, to the remaining range left on the bus, to successfully completed charge sessions, and basically the energy level both on board and the time of charging. So, you know, we work with our customers to find out what useful information that they need to manage their deployment, and we tailor our dashboards accordingly.
Thank you. Jonathan?
Well, it's very similar. So our telematics partner, basically you can see and read and monitor anything on the bus. Is fully connected to both like the bus body side and the powertrain side, everything, people counting the entire systems. But the important point is working with the customer to figure out what they actually want to view, because this data can be very overwhelming. It's a huge amount of data. You could get very lost in it. So really trying to talk to the customer and find out what exact data points are most important for your transit system, and how do you want to view them, how many days a week, who needs to see them, you know, what do you want to look like? Is it just raw data? Is it graphs? Is it reports? These are important questions.
My turn. So it's similar on our side as well, but just to echo Jonathan's comment, it's really about working with the transit agency to see what do you want to see, because there's so much data available. So location of the bus, energy uses of the bus, what happens en route at different type of route topography, so on and so forth. And it's also about training the workforce in order to understand the data itself. So diagnostic troubleshooting trees, understanding how to read the data. It's really not only the data, it's what data you need, but it's also how can you read the data so that it's actually useful. So working closely with our customers, and we're agnostic in terms of data services, and we have our own as well that we can offer in the cases that the price point for the current data services is not appropriate for our customers. So working closely with the customer to make sure that they look at the right data and they can interpret the data properly as well.
Thank you so much. And looking at our time, I was going to squeak in one more quick question, but I think it's better that we're going to give our panelists a final minute or so each to talk about key items that you'd like to leave with our audience today. And so I'll go back with our order that we did the presentations. I'll start with Jennifer, and we'll go to Milan, and then Jonathan. Thank you.
Certainly. So First of all, thank you again for the opportunity to participate in the panel. It's been an honor. For NFI, our main priorities are twofold. First one is bus and charger availability and reliability. So many of our improvements that we are introducing over the coming months have to do with ensuring that that is at the highest possible levels. And then the second is range. We understand right now that right now it is not a one-to-one replacement for all fleets and all routes. And we have many innovations that we're working towards to get to the point where the range is equivalent to its diesel bus equivalent. But to do that, there are a few innovations in battery energy density that need to come down the road, as well as a few other innovations in efficiency and vehicle weight. And so we look forward to that incremental innovation and how we introduce those over the coming months. Thank you.
Thank you, Michelle. So, I don't see the video of Michelle anymore. That's too bad. So thank you, Michelle, for this opportunity, for the question. Thank you to Kutrik. This has been great. And of course, my fellow panel, Jennifer, Jonathan as well. So for Novabus, we know this is a transformation and we want to be part of this journey with our customers. So we want to constantly look at it with your perspective in mind. That's very, very important to us. Of course, it's about the route planning, ensuring that you can go from point A to point B, irrespective of the propulsion used, and that we want to make sure that for the end user, it is transparent. Working as well in the most cost-efficient, easy deployment solution as well for this market. So we want to be part of this transformation. We want to journey with you. We want to try to alleviate some of the building blocks so that there's a successful deployment of battery electric bus, successful deployment of fleet transportation for the masses. Thank you so much.
Thank you, Milan. And thank you, Jonathan. Go ahead, please.
Yeah, thanks, everyone. It's been great presenting with all of you. And it's just been an honor. So I think, what I would like to leave the audience with is Vicinity Motor Corp is really trying hard to reduce the cost of entry into the EV market, getting rid of as much infrastructure as possible, additional things you have to buy when you buy the bus, and really trying to future-proof charging so that you're not buying chargers or charging infrastructure that is useful today and not useful tomorrow. So trying to simplify that so that, going forward, it's somewhat similar to fueling a diesel bus where, it doesn't matter which bus you have, the fuel's all the same, and they all, you can buy one or the other and it will work in your fleet and at your depot. So just trying to work towards that. Thank you.
Well, thank you all very much. Really appreciate our discussion today. I'm sorry to the audience that we couldn't get to all of your questions, but I'm sure that there will be a way that we can get through. I wanted to say thank you very much to Kutrik for hosting this conference, and for ZEV Clean Power, our sponsor for today's panel discussion. And the last thing I'd like to say is see you in the next session. We have a sponsor exhibit from New Flyer coming up. So see you at noon over at the sponsor exhibit.